Okay, problem number 4 of worksheet 4. We're trying to figure out the tension in the guy wire, and we're trying to figure out the forces down here on the hinge. Okay, so let me go ahead and draw a free body for this. Okay, this is the beam that has the tension on it and the hinge forces, so that should be a good free body diagram. And there is a tension force that's going to be the same as the weight of the sign. There's going to be a tension force this way, which is what we're trying to find. There's going to be a weight of the beam itself, and there's going to be some forces on the hinge, and I'm not really sure which direction. I'm going to have them like this and like this. I could be wrong here. I'll find out if I end up getting a negative sign. Let me label these. This is the tension force on the beam from the guy wire. This is the, I'm going to call it W, but it's really, well, maybe I should call it tension. Tension on the beam from the sign. This is the weight on the beam from the earth. This is the force on the hinge, or excuse me, on the beam from the hinge in the X direction. And this is the force on the beam from the hinge in the Y direction. And I can write a couple equations here. One equation would be FBHY plus TBGY would be equal to TBS. And the other equation would be FBHX equals TBGX. Okay, so wait a second. Oh, I need to modify this one a little bit here. FB TB. Oh yeah, no, that's fine. Yes, I need to modify this slightly. Forgot the weight of the beam. Plus the weight of the beam. Okay, now it's correct. Okay, I know the weight of the beam and I know the weight of the sign, so I can go ahead and plug those in. So it's going to be FBHY plus TBGY equals TBS would be 215 newtons plus 155 newtons, and FBHX equals TBGX. But at this point I've got too many unknowns. I've got 1, 2, 3, 4 unknowns. So I need to do a torque equation, and I can get rid of, these are my unknowns, this one here, and this one. So I'm going to get rid of the torque from those two by putting a pivot point down there. For my torque equation, it's going to become the torque from the guy wire is going to be equal to the torque from the beam plus the torque from the sign. And so this is going to be TBG times 1.35 meters times sine of 35 degrees equals 155 newtons times, let's see, the whole thing's 1.7 meters long, so half that would be 0.85, so 0.85 meters times sine of 90, which is just 1, so I'll leave that off, plus 215 newtons times 1.7 meters times sine of 90, which is again just 1, so I'm going to leave that off. Okay, so now I can solve for the force in the guy wire. So TBG is going to be equal to (642 newtons). And once I have that, then I can go ahead and figure out the force on the hinge in these different directions, the y and the x direction. Okay, so I think I'm going to go ahead and do that. Okay, so let me delete this too. So this TBY is going to be equal to (642 newtons times the sine of 35 degrees. And so that means I can figure out the force on the hinge in the y direction. So 215 plus 155 minus 642 sine of 35 gives me 1.76 newtons. So the force on the beam from the hinge in the y direction is equal to 1.76 newtons. So in other words, the hinge isn't providing much of an upward force. Alright, let's figure out what the force on the hinge will be in the horizontal direction. Oops. Okay, so I've got the force on the boom from the hinge in the x direction is equal to the tension from the guy wire in the x direction. So that's going to be 642 newtons times the cosine of 35 degrees. Oh, what's going on here? Here we go. Not sure what's going on. Put it over here. Okay. So then I can solve for force on the beam from the hinge in the x direction would be equal to 526 newtons.